This is lesson 3.7, elementary algebra, linear inequalities in two variables. Now that is just a complicated way of saying we're going to do kind of along the line that we just did, only a little bit different. I don't know that that's any easier to understand, but anyway, we're just going to jump right into example 1 and show you what we're doing here. When we have an inequality like that, and again, the only difference between an inequality and an equation is that symbol right there. Everything pretty much is done the same way until we get to the end. So, if we are graphing this, first of all, we need to find two numbers that when we add them together, we get a number that's either equal to 4 or less than 4. Those are our options. So if I were to make a little table here, and let's say I put 0 in there for x. If I put 0 in for x, 0 plus 4 would be 4. What if I put 1 in there? 1 plus 3. If I put 2 in there, 2 plus 2. Okay? And then if I graphed it, I'd have 0, 4, 1, 3, and 2, 2. And drew my line. Okay, that is a graph of x plus y equals 4. But, let's move this over a little bit so we can, come on. So we can, let's see, we're at 0, 4. So we can see this here. Okay, so there's a difference. This one is an x plus 4, or y equals 4, and this is an x plus y equals or is less than 4. Okay, so what we're looking for is all numbers that are going to make this a true statement. So what numbers make x plus y equal to 4? Well, these right here, plus a whole bunch of others. You know, any point along this line would be x plus y equals 4. So that's kind of our boundary line. We're also interested in all numbers that we can put in here for x and y that would give us a number or a point that's less than 4. So for example, if we made another graph here and we put 0 and 1 in there, is 0 plus 1 less than 4? Yes, it is. So 0, 1 works as a possible point. In fact, if we used any points down here and plugged those points, the x and the y, into this equation, we would get a number that is less than 4. All right, let's try another one. Let's try 3, 0. So let's put 3 and 0 in here. 3 plus 0, is that giving me a number that's less than 4? 3 plus 0 is 3. Yes, it is. So that is also a true statement. So what I'm looking for is in this section is not just numbers that lie on this line, although those are important because they can be equal to 4, but I'm also looking at all the other numbers that when I add them together, I get a number that's less than 4, or less than this line, or below this line. Okay, so that's example 1, and I kind of hesitated doing example 1 just because I think they kind of start out a little bit too fast. I would have gone another direction, but I already was committed, so I did that. Let's look at example 2, and we'll see. Let's make this smaller and see if we can kind of get rid of any confusion. It says graph the solution for the set y is less than 2x minus 3. So we're graphing the solution. So it is already in y equals mx plus b form. The only difference is this is a less than sign and this is an equal sign. Do it as if it's an equal sign. We're going to do it as if it's an equal sign in order to graph the line of this equation. And then we'll look at the less than sign there. So, all right, first of all, what is my y-intercept? My y-intercept is always that number right there, -3. And then remember, you take the slope, which in this case is 2, or 2 over 1, which is y over x, and you start at this point, and you go up 2 over 1. Up 2 over 1. Okay, right there. All right, so that is the line of y equals 2x minus 3. Now let's look at this, the less than sign. So what we did is we came up with a boundary. It says y is less than 2x minus 3. So y, it means that all the points below this line are going to work because it says less than. So we'll do some checking on that in just a minute. But when this says less than, can y be equal to 2x minus 3? That's what this line is 2x minus 3. Can it be equal to that? No, it cannot. It has to be below it. It cannot be equal to it. So that means that the answer does not lie on this line, which means we cannot include that line in our answer. So what I'm going to do is I'm going to erase that line, and I'm going to draw it again, but since it doesn't include the line, I'm going to draw a dotted line. A dotted line means that that's the boundary, but it's not part of our answer. Now, if this were a less than or equal to sign over here, then yes, we would draw a straight line, a solid line. But since it's just a less than, we can only draw the dotted line there. All right, so let's see which side of this line we're going to shade. Are we going to shade this side or this side? It's really easy to come up with a way to do that. All you have to do is draw your XY and pick a point on either side of the line. It doesn't matter. I'm going to pick 0, 0 over here. Doesn't matter what point you pick. And I'm going to put 0 here and 0 here. So what I'm going to do is I'm going to plug those into this inequality. I'm going to say 0 from here is less than 2 times 0 minus 3. And see if this is a true statement. 0 is less than 2 times 0, 0 minus 3. Is 0 less than -3? No, it is not. So that means it is not one of the answers, which also means that nothing over here is one of the answers, which means all of the answers are on the other side of the line. So you just try one point, put in there, and see if that point works. If it does, then everything on that side of the line is shaded. If it doesn't work, then nothing on that side of the line is shaded. So that's all we're doing with this. So let's jump to example 3, and keep working at it. One of the things that's very important is we first of all have to get our equation in that format. That will make things a lot easier. So let's go ahead and get rid of all of this and put example 3 up here. 2x plus 3y is less than or equal to 0. So we have to put it in this format. So let's move stuff around. We'll move the x over. Now remember, the sign does not change because we're subtracting by 2x, not dividing or multiplying. Okay, we can put the plus 0 there, just because it's there. All right, now we're going to divide by 3. And we're dividing by a positive 3, so the sign again does not change. Split these up. And 0 over 3 is just 0, so we'll just put a plus 0 right there just to help us. All right, so y-intercept is that number right there. It crosses the y-axis at 0. Okay, and then the slope, -2/3. Remember, that's the y over x. So from the y-intercept right here, we go down 2 over 3, and we come up with a point right there. And then we draw our line. Now we have to decide whether that line is going to be solid or whether it's going to be dotted based on that symbol. Because of the equal sign symbol, it's going to be solid. Now we have to decide whether our answer is above or below that line. And again, all we do is take a point. It does not matter what point we pick. We just take a point. Let's pick a point like 3, 0, so that we're at least dealing with a 0. And let's plug that number into this original equation. 2x plus 3y is less than or equal to 0. So let's put a 3 in for x and a 0 in for y. And we get 6 plus 3 times 0 is 0 is less than or equal to 0. So the question is 6 less than or equal to 0? No. So that means that this point does not work, which means no points above here work, which means the answer is all the points on the other side of the line. So you just shade like that and you're done. So let's do one more. So this is example 4, and remember, whenever you have something like x is equal to 5 or y is equal to 6, you have two different lines. This one, you have a vertical line, and this one, you have a horizontal line at these positions. So when I have x, oops, that's not the eraser. If I have x is less than or equal to 5, I am looking for a vertical line because it doesn't have a y value, and I'm going to be at 5. So I'm going to go straight up and down 5, and it's going to be solid, again, because it's a less than or equal to sign. Because of that little line there, it can equal this line. If that sign was not on there, then it could not equal 5, and it would have to be just the points on this side or this side of the line. It could not include the line. But because of the equal sign, it can include the line. So what do we shade here? Well, let's look at point 0, 0. Let's see if that works. Is 0, because point 0, 0, what I'm interested in is just the x part. Is 0 less than or equal to 5? Yes, it is. Let's try a number over here. Let's try 7. 7, 0. Is 7, which is the x value, less than or equal to 5? No. This is yes, and this one's no. So that tells me that to the left is shaded, and to the right is not shaded. So we have an answer just like that. And that's it for lesson 3.7. And as you look at the problem set, you're just doing what we just did. 1 through 24, you're just graphing, doing exactly what I did. 31 to 41, you're just kind of doing some review stuff. It's called maintaining your skills for a reason, because it's working at helping you remember some of the stuff that you've done in the past. So you might want to jump back to some of your old notes and stuff, or your homework, and remind yourself about how to do that. It's just a way for you to practice and continue to review previously learned stuff, because that's the difference between math and some other subjects. Is math, you can never forget what you learned in the past. It'll always come back and bite you, and you'll always need it. So that's a way to continue maintaining your skills. So anyway, that's it for lesson 3.7 in one video.